Good afternoon. Today I am going over packet number 9 for that is due next week Friday on March 21st. So our first page says Bob's Super Ball bounces exactly half the height from which it is dropped. He drops the ball from the top of a building that is 64 meters high. So he is up here at 64 meters. He drops the ball. How high is it going to bounce on that first bounce? So it's going to be half of 64 for bounce number 1. So that is going to be 64 divided by 2 is 32. Then it's going to bounce again, but it's going to bounce up again half of that height for bounce 2. And then you need to find for bounce 3, bounce 4, 5, 6, 7, 8. So you need to go all the way down to bounce number 8, starting with that first bounce up at 32, all the way down to bounce number 8, and tell me how high it is going to bounce for that 8th bounce. Our next page is the page that I sent it through to be copied, and the copier messed up when it was doing the copies. So the next page is actually the last page of your packet. This one says a florist is making identical bouquets from 36 tulips, 27 roses, and 18 lilies. No flowers should be left over. What is the greatest number of identical bouquets that the florist can make? So we have 3 numbers, 36, 27, and 18. You need to find that greatest common factor of all 3 of those numbers. What is the biggest number, the greatest number that we can divide out of all 3 of those numbers? That is how many bouquets there are going to be. So find that greatest common factor, that's your number of bouquets. Then you're going to tell me how many tulips will be in each bouquet, how many roses, and how many lilies. So if there are going to be 3 bouquets, that is not the answer, but if there are 3 bouquets, if that was our greatest common factor, how many would there be of the lilies? So 18 divided by 3 would give me 6. They would be able to divide up those lilies into 3 groups of 6. So you would put 6 lilies. So whatever number you find to be the greatest common factor out of those 3 numbers, you should be able to divide each of those numbers by that number of bouquets and tell me how many of those flowers will be in each of those bouquets. So it's the factor buddy. So like I said, if you were dividing it up into 3 groups, you would tell me the factor buddy to get to 18, the factor buddy to get to 27, and the factor buddy to get to 36 of those 3 bouquets. Again, not the correct answer. You need to find that greatest common factor to do that. Now our next page is our 5-card challenge. You need to use those numbers to equal 3. You need to come up with 12 points for it. Then the next one is our pattern figures. So let's fill in what we know for the total blocks. Math 6 has to just do the total blocks column. In our first figure, there are 9 blocks. Then we see 36 blocks. Then we see 81 blocks and 144 blocks. So let's see what kind of pattern we can find in that. Thinking about what my favorite kind of numbers are, those perfect squares. 9 is a perfect square for 3. 3 squared is 9. 36 would be 6 squared. 6 times 6 is 36. 81 would be 9 squared. 9 times 9. 144 would be 12 squared. There is a pattern, 3 squared, 6 squared, 9 squared, 12 squared. See if you can figure out what the next number that we're going to square is, and write the answer here. And keep on going to complete your pattern. Always be looking when we do those pattern problems. Lots of times we will see perfect squares popping up. Next page says find the area of the shaded region. The figure is a square with a circle inside of it. Round your answer to the nearest hundredth. All work must be shown. So for the area of the figure, that is the full figure. So we see one side is 10, it is a square. So what is our other side? Knowing that the area of the square is the length times the width, put your answer up here. So tell me what you multiplied to find that full area. Now, to find the shaded area, I don't have a formula for us for these goofy shapes. That is the shaded area, but I can tell you how to find the area of the white circle. To find the area of a circle, you do pi times r squared. Now, r is that's our radius from the middle of the circle over to the side. We know what it is from side to side is 10, so our radius is going to be half of that from the middle to the side. So half of 10 is what we would put here. That is what we are going to square and multiply that by pi. That tells us the white circle. Remember, to find the shaded area, we take the full area and we subtract out, we take away the white area. Oops, let me spell white correctly. So we're going to take away the white area, and we are left with the shaded area. The shaded area is what we want to put on this line. So find your full area, find your white area of the white circle, and then you subtract them to be left with the shaded area. Our next page is our volume page. So we have some of the lengths and the widths and the heights filled in. First thing we want to do is make sure we know all of our formulas that we want to use for our volume. For a rectangular prism, it's length times width times height. For our cube, it is side cubed. So length times width times height, but they're all the same number. So remember, we want to multiply that same number 3 times to get that 27 volume. For the triangular prism, it's 1/2 of the length times the width times the height. For our pyramid, it is length times width times height divided by 3. For our cylinder, it is pi r squared times the height. For the cone, it is pi r squared with the height times the height divided by 3. And our sphere is 4/3 pi r cubed. Now remember, we want to use opposite operations to find our missing length that we are trying to get. So if we know our volume of our rectangular prism is 60, we know the formula is the volume equals length times width times height. So our volume of 60 equals length of 3 times the height of 4, the width of 4 times our height. Use opposite operations to get the height by itself. So if we are multiplying 3 and multiplying by 4, we want to do opposite operations to move it over to the 60. So we want to divide by 3 and divide that by 4. And what we are left with should be our height. So make sure Math 6 has to do 2 of these formulas or volume problems. You can do more, you can challenge yourself. That is always exciting to see. And our last page is our graphing page. So this says, consider the data and answer the question for your class. You can attach a sheet, a separate sheet of paper, just staple it on the back, or you can use this empty white space. I'm just going to use this as my example. We are making a graph. We do need to use correct labeling. So we're going to want to label on the x-axis down below. You're going to want to put your Monday, your Tuesday, your Wednesday. What are those? Those are days of the week. So you want to put that label down below. Then coming up the side, you're going to put your numbers. You might skip count to make them all fit, because these are all numbers, but they are numbers of what? Label your y-axis. Then you can figure out each tally mark stands for a customer, figure out how many customers there were each day, make yourself a lovely bar graph to show that. And do not forget that we have questions to answer. We are not just making our graphs. We do need to say how many customers come during the week and how many come during the weekend. So you need to make your graph and you need to answer your questions. If you still have questions on this math packet, make sure you come and see me. Remember, if you turn it in before next week Friday, you will have a chance to redo and fix up mistakes that you make. It is due next week Friday, so everybody needs to have it turned in for good by the 21st. I hope you are well, and I hope to see you soon. Have a wonderful day.